while the entire world is pouring hundreds of billions of dollars in Gen AI, there is one man who's betting against all of it. His name is Yann LeCun. He is not some layman commentating on AI. He's one of the founding fathers of modern AI. Yann is a Turing Award winner and the former chief scientist at Meta. Yann is the creator of convolutional neural networks and PyTorch, which are building blocks of all forms of AI, including LLMs. Now, why would Yann LeCun bet against LLMs, which are basically a derivative of his own research? What is his definition of AGI then? Why does he think LLMs won't lead to AGI? In today's video, we will discuss the emergence of AGI through Yann LeCun's lens. To understand why Yann LeCun is fighting the world today, we have to go back to 1969. In 1969, the kings of traditional AI, Marvin Minsky and Seymour Papert, published a book called Perceptrons. In this book, they made a rather conservative prediction that simple neural networks could not even solve a basic logical problem like XOR function. They argued that because a simple network could only draw a single straight line to separate data, it was a dead end for AGI. Now, imagine a chocolate vanilla cake like this. Now, if you want to cut out just the vanilla out of chocolate with a single cut, there is no way to do that. You can try it any way you want. Likewise, it was not possible to separate the ones and zeros of the XOR output based on the outputs with a single neuron network. This book sent waves in the AI world. Due to this, in the early 1980s, artificial intelligence was a dirty word. Companies started building what they called expert systems, which all of us use. These were giant databases of hard-coded if-then rules written by human programmers. If a patient has symptom A and symptom B, you can diagnose it as disease C. Tech giants promised these systems would revolutionize the world eventually, but they were incredibly fragile. The moment they encountered something slightly outside their rules, the systems broke. As when these systems failed to deliver, funding vanished. Companies went bankrupt, and the first massive AI winter froze the entire world. But a young Yann LeCun had a different idea. He didn't want to program rules into a computer. He wanted to build an artificial brain that could learn rules on its own, a multi-layered neural network. But in the 1980s, Yann LeCun looked at the same XOR or the cake problem and asked, why should the cake stay flat? Yann realized that if you stack multiple layers of artificial neurons, called hidden layers, you can fold the plate. By folding the plate, you can actually lift up the chocolate flavors, and now you can take a knife and make one clean cut right under the folded chocolate layer, separating vanilla and chocolate perfectly. This led to deep learning in AI. Yann LeCun proved everyone wrong for the first time. But because neural networks were considered a joke by academic gatekeepers, Yann had to actively rebrand his works under titles like pattern recognition just to keep them from being thrown into the trash. He was operating in near total isolation. In 1989, Yann LeCun figured out the exact mathematical instructions to let the network fold itself. This is the famous process called backpropagation, a feedback function using which neurons' weights are adjusted constantly. This led him to build the first ever convolutional neural network. He called it LeNet 5 network. In 1989, this LeNet network was reading handwritten checks for banks across America and played a significant role in banking automation. Yann had proven the establishment completely wrong for the second time. In 2013, Mark Zuckerberg recruited Yann LeCun to set up Facebook's AI and research lab, which was called FAIR. As part of FAIR, Yann created an open-source PyTorch. PyTorch is the go-to machine learning framework in the industry even today. Although Yann did not contribute to Llama models technologically, he played a significant role in open-sourcing the model. In 2018, Yann LeCun, alongside his mentor Geoffrey Hinton and peer Yoshua Bengio, won the ACM Turing Award, the Nobel Prize of Computing. Neural networks were now the foundation of the modern world. In the late 2022, ChatGPT was released, and it used the very same neural networks that were created by Yann and his colleagues. And suddenly, a massive ideological split happened among the godfathers of AI. Geoffrey Hinton resigned from Google to warn the world that AI was becoming an existential threat to humanity because he believed LLMs could lead to AGI. He feared that digital intelligence would rapidly bypass biological brains, escape human control, and lead to our extinction just through LLMs. But Yann LeCun refused to align. In fact, he publicly called the fear of AGI doomsday unscientific. Yann's argument was simple. Today's AI models are large language models, LLMs, and they are trained entirely on text. He pointed out that a human child learns how the world works, such as gravity, space, and social cues, long before they even learn language. By the time a child is 4 years old, they have processed more data through their eyes than all the text on the entire internet combined. LLMs, on the other hand, have zero physical grounding. They do not know that if you pull a table runner, the water bottle on top of it will fall. They are simply predicting the next word based on probability and pretending to be reasoning. And the other important challenge is the data availability. These LLM models that we have today, they have already used up all the data that was ever produced and made available on the internet. So if they are not on AGI yet, and if they need to get AGI, they will have to be trained by AI's own data, which is not going to help them much. To Yann, calling ChatGPT intelligent is like calling a highly advanced tool conscious. It is a parlor trick, and trying to reach true human level using only LLM is a complete dead end, according to him. So how does Yann LeCun plan to build AGI? Yann LeCun's answer is JEPA, the Joint Embedding Predictive Architecture. To understand why JEPA is revolutionary, let's look at Yann's favorite example, the water bottle. If we want an AI to predict what happens when a hand pushes a water bottle off a table, traditional generative AI models try to predict the future pixel by pixel. They waste massive mathematical energy trying to predict the exact chaotic trajectory of every single splashing water droplet, the way light refracts through the plastic and the random dust floating in the air. All of this using the previously trained language or photographs or videos. Because these microscopic details are highly unpredictable, the AI gets overwhelmed by this noise. It either outputs blurry frames or starts hallucinating entirely. JEPA, on the other hand, solves this by operating entirely in abstract thought space. First, it passes the before image of the upright bottle through a context encoder. This encoder strips away the table color, the background details, and the lighting, turning the scene into a simple high-dimensional mathematical coordinates called embedding. And then secondly, it passes the after image of the spilled bottle through a target encoder, mapping it to object, state, and table, and so on. Finally, the central predictor calculates the transformation entirely within this abstract thought space. It predicts that gravity will tilt the cylinder and wet the surface. It completely ignores the shapes of the individual splashing droplets because those details were filtered out by the encoders, and it has learned the physical law of gravity without ever needing to paint a single pixel. Even models like Google's Genie, which are hailed as interactive world models, still fall into the pixel trap because they generate visual game frames pixel by pixel. JEPA is different. It is pure, uncompromised, abstract mathematical thought. For years, Yann championed this open source world model research at Meta under Mark Zuckerberg. Meta even open sourced early versions of JEPA like iJEPA and vJEPA. But towards the end of 2024, the commercial pressure of the AI race shifted. Meta needed immediate consumer products to compete with Google and OpenAI. So they poured their focus into integrating generative LLMs and chatbots directly into Instagram and Facebook. Basic research into non-LLM long-term architectures such as chips deprioritized within Meta. So Yann made a massive move, and along with a world-class team of scientists and builders, he co-founded AMI Labs, which stands for Advanced Machine Intelligence, with an astonishing $1.03 billion of seed fund backed by some of the biggest investors in the world, including Mark Cuban and AMI Labs is now building the next generation of AI designs where safety, reliability, and continuous planning actually matters. They are headquartered in Paris and they have an office in New York. far away from Silicon Valley, where all the chaos is happening in AI. The battle for AGI is a fundamental war of philosophies. Will we reach general intelligence by building massive LLMs that guess the next word? Or will we reach it by building machines that passively observe, understand, and plan within our physical reality? If history has taught us anything, it is betting against Yann LeCun is a losing game. Yann survived the AI winter, proved the skeptic strong on neural networks, and now he's building the physical brain of tomorrow's robots. What do you think? Let me know in the comments below. If you love this deep dive, make sure to hit that subscribe button, turn on notifications, and share this video with your friends. This is Selva Jagannathan signing off, and I will see you in the next video.